Hi, this lecture video right here is an introduction to isotopes. So first, what are isotopes? Isotopes basically refer to atoms of the same element. However, this atom right here of the same element have different masses to them. For an example, one carbon atom with a mass equal to 12 versus another carbon with a mass equal to 13. These two copies of these two carbon atoms right here are then referred to as the two isotopes of carbon. So how can two isotopes of the same element will have different mass to them? Why do they have different mass? It turned out because of the following. The isotopes have different mass because they have different number of neutrons in them. And because the mass of the neutron is significant. Therefore, by having a different number of neutrons, the mass of the atom would then be different from each other. And we have to also realize that the number of protons must remain the same in order for them to be isotopes, right? Because if they would have different number of protons, then that means they will no longer be the same element anymore. And going back here, we can see that the mass number is then equal to the number Z plus the number n. So in this case right here, the number of protons is the same for the different isotope. So this is basically same for the same isotope, for different isotope. However, it is the number of neutrons that is now different for different isotopes. And because the number of neutrons would then be different while the number of protons remain the same, therefore the mass number would be different for the different isotope. So some elements have multiple or exist in several versions that we call the isotope. So some elements have multiple isotopes with the different percentage of natural abundance to them. So this basically means that they do not all exist equally. For an example, hydrogen has two different types of isotopes. We can have hydrogen with a mass equal to 1 and hydrogen with mass equal to 2. So these are the mass in AMU right here. And these are the percentage of abundance of the two different isotopes of hydrogen. So in nature, 99.99% of all of the hydrogen would be the hydrogen 1 isotope, whereas there be a small amount, 0.0115% of it, has the mass equal to 2. Versus for helium, helium also have two common isotopes to them as well, and these are the masses of the two isotopes and the percentage of abundance of the two different isotopes right here. And as for carbon, of what we have seen already, carbon has two common isotopes to it. One is carbon 12, and this carbon right here have the mass equal to exactly 12, and this is 98.92% abundant. So there is a smaller 1% of carbon that exists in this carbon 13 isotope right here with this mass. And here example of the other element and the different isotopes that they have. So many elements actually have various isotopes to them, and this table right here are just an example of a few. So here we can also see that sulfur, in this case right here, has up to 4 different isotopes to them, and these are the masses and the percentage of abundance of the 4 isotopes of sulfur. Now, how do we represent an isotope? Then an isotope can be represented by first its element name followed by its atomic mass number, because the mass number of different isotopes are different. So therefore it is important that we refer to them or we use them to distinguish between the different isotopes. For an example, carbon 12 and carbon 13 are two isotopes of each other. And when we name this, when we write name for this, we can say this is C12 and this is C13. And when we name them, we can call this carbon 12. And this is named as carbon 13. So we have to use the 12 and the 13 whenever we refer to the different isotope of carbon. And this is like how we were able to find the number of subatomic particles for a neutral, atom, and the ion. We should also be able to figure out the number of subatomic particles in isotopes as well. For an example, carbon 12. So when this is the carbon 12, and the nuclear symbol of the carbon 12 is carbon with 6 here and 12 up here. So this tells us that its mass equal to 12. So that's how we know to put 12 over here. Versus for carbon 13, its nuclear symbol will look as follows: C, and still 6 right here, and 13 over here. Now, because we know that this is carbon already, and sometimes carbon will have 6 protons to them. So sometimes listing this 6 right here is quite redundant a little bit. So this is the reason why that sometimes we simply ignore that 6 when we put 13 over here, because we know it has to be 6 already, since this is the carbon atom. But by convention, so we can either keep the 6 here or we don't have to include it, and both of them would be correct. And now as for the number of subatomic particles in the carbon 12 isotope, I have 6 protons, and because this is still neutral, so therefore I have 6 electrons. And now it would then have 6 neutrons. Because if we were to take this atomic mass minus this number 6, that gives us 6 neutrons. In the case of carbon 13 isotope, it has 6 protons to it, because again it is carbon, so we know it needs to have 6 protons. And because this is neutral, we don't see a charge listed over here, so this is neutral, and therefore you have 6 electrons to it. And in this case right here, its atomic mass is 13, and now its atomic number is 6. By taking 13 minus 6, this gives us 7 neutrons. So those are how many ever subatomic particles that carbon 13 would have. Let's now try a few more examples. So here in this case right here, we will then see that the nuclear symbol of nitrogen will be as follows: N. And in this case, we've been told that this is the nitrogen 15 isotope. So 15 has to go up here. And now its atomic number is 7. So we can either put the 7 here, or we can omit the 7. And that would still tell us the same thing. And in this case, nitrogen nitrogen 15 will then have 7 protons. And because neutral, so therefore it needs to also have 7 electrons to it. And in this case, because the atomic mass is 15, 15 minus the atomic number 7, this gives us 8 neutrons. So please try this all the following example.